In this video, we're going to look at covalent bonding, and we'll start with a review of ionic bonding, which you've learned about in grade 9 and grade 10. We've learned that atoms are most stable when their valence shells are full, or complete. Which usually means 8 electrons. So another word for that is the Octet Rule. In most cases, 8 electrons will complete the valence shell. Some exceptions would be elements like hydrogen or helium, which would be complete with 2 electrons in their valence shell. So anyway, when atoms have a complete outer shell, that means that they would have the same electron configuration as the nearest noble gas. And this explains why noble gases are not reactive, or not, at least not very reactive, because they already have full valence shells. They don't need to gain or lose electrons. Okay, we've also learned that metals will lose electrons to get full valence shells, and nonmetals will gain electrons. And when they do that, you end up with positive and negative ions, positive metal ions, negative nonmetal ions, and they're going to be attracted to each other because of the opposite charges. And when those ions are attracted to each other, you get what's called an ionic bond. Ionic because it's formed of ions. But is there another way for atoms to get a full valence shell? Well, obviously yes, or I wouldn't have asked the question. Nonmetals can complete their valence shells by sharing electrons with other nonmetals. So, we've talked about how nonmetals want, we're using that word want, to get a full outer shell by gaining electrons. Well, if you have two nonmetals, they both want electrons. One way they can solve the problem is to share the electrons, or at least some of the electrons that they do have. A familiar example would be water, H2O. If we draw the Bohr model for oxygen, I'm going to do a simplified Bohr model here. This is the symbol O. This is not a shell. Okay, oxygen has 8 electrons. So it's going to have 2 in the first shell, and then 6 more in the valence shell. 8 total. Okay, hydrogen has 1 electron, 1 valence electron, and I'm going to draw its electrons using an X just to distinguish them from the oxygen's electrons. And there's another hydrogen with its 1 electron. Now you see the way I've drawn it here, the oxygen atom, it has 8 electrons now in its outer shell, so it's most stable. And hydrogen now has 2 electrons, right? The one that it brought and the one that oxygen donated to be shared. So by sharing electrons, all the atoms get a full valence shell. And so this whole molecule then would be more stable or at a lower energy than those atoms would be by themselves. Okay. So at this point here where they're sharing electrons, we can see their shells overlap. It will carry on in the next video.